Curious about how decision trees work? In today's video, we are going to build a decision tree from the ground up. You will learn how to load and pre-process data and visualize the tree and create a powerful model. Grab your code editor and let's dive right in. Let's begin by gathering our tools. We are using libraries like Pandas for data handling, NumPy for computations, and visualization libraries like Matplotlib, Seaborn, and Plotly. These help us analyze, clean, and visualize the data efficiently. Here, we load the dataset from drug.csv, preview the first few rows, check its shape to understand the size, and list the column names to see its structure. In this loop, we iterate through the selected columns, print the column name, and display the count of unique values for each column to understand the distribution of data. We check for missing values with isNA method and get a summary of the dataset using info method. Here, we apply label encoder to each of the selected columns to transform categorical values into numerical labels, making them suitable for machine learning models. We use describe function to generate a statistical summary. We use count plot to visualize the counts of each drug category. We use scatter plot to visualize the relationship between age and NA to K with points colored by the drug category. This histogram plot visualizes the distribution of NA to K, distinguishes categories by drug, and includes a smooth KDE curve for clarity. We use heat map to display the correlation matrix with annotations showing the strength of relationships between numerical features. The pair plot visualizes pairwise relationships between features colored by drug categories to reveal patterns and correlations. Here, X contains the features by dropping the drug column and Y holds the target variable, which is the drug column. The decision tree classifier initializes a decision tree model ready to be trained on the data. The params dictionary defines the hyperparameters for tuning the decision tree model, including options for tree depth, splitting criterion, minimum samples for splitting, and the number of leaf nodes. We use randomized search CV to search for the best hyperparameters for the decision tree model by randomly sampling from the specified parameter grid, performing cross validation, and fitting the model on the data. The R search best score gives the highest cross validation score achieved during the search. R search best estimator returns the model with the best found hyperparameters. R search best params shows the optimal hyperparameters for the model. We use the train test split to split the dataset into training and testing sets, with 30% of the data reserved for testing. We create a refined decision tree model by specifying the Gini criteria. and setting the minimum samples required to split a node to 12. The refined decision tree model is trained on the training data using fit. The score function returns an accuracy of 98.33%, indicating how well the model predicts the target variable on the test data. And there you have it, an end-to-end journey into decision trees, all coded from scratch. From pre-processing to data visualization, the data to visualize the model and building the model, we have covered it all. If you enjoyed this, don't forget to hit the like button, subscribe the channel and turn on notifications. Let me know in the comments how you are planning to use decision trees in your projects. Until next time, keep learning, keep coding and stay curious.